Next, let us see the derivation of cross belt drives. Already we have seen the derivation of open belt drives. So cross belt drive we will be doing little bit faster in order to have a good practice over it, because initially you derived the length of open belt drive that looks very big. So it is not so big. The concepts and understanding itself is somewhat like more complicated here, but it is not like that. We will understand the same thing with the help of cross belt drive. So let us see the derivation of length of cross belt drive. Again, cross belt drives are one which having the direction of rotation of driver and driven opposite direction. Those two will be rotating in opposite rotation. So this is driver wheel, same thing, same concept, and this is driven wheel. Since the direction of rotation of driver and driven is in different direction, you can have same wheel diameters and same n, but it will not satisfy the condition of velocity ratio. That is the limitation of one of the flat belt drive. So again we have to keep driver pulley smaller one, we have to keep driven pulley smaller one, driver pulley larger one. So this direction of rotation is clockwise and this will be rotating in different. So let us see the terminology. This is R1, radius of driver, and this is R2, radius of driven. Same notations I am going to use here, and these two distances are center distance O1, O2. What I will consider a point. I will connect a belt first. I will take this point and I will connect this. So this is again E and F. E is the point where it leaves the belt leaves the driver pulley. F is the points where belt enters the driven pulley. Again, this is one, and again that's why the name cross belt drive. So this is EF, and this we have taken G, H, and this is J and K. Same notations we are using here, but here observe total length of the belt drive will be varying here. So this is, I will join these two, got it? I will join these two, again I will join H, I will join F. So this angle is alpha, this is also alpha, again this is alpha, this is alpha. Then I will be extending this line and I will be connecting to O2. This line is nothing but M. So this is a straight, you have to know. Let us see the length of cross belt drive. So total length will be equal to arc length of same this arc length G, J and E plus EF. You have to consider EF. See here, this one EF, then arc length of or arc of FKH, arc of this one FKH, then finally this H into G. Again same like an open belt drive, we will be writing again GJE is nothing but GJ plus JE. So we can write it as 2 into GJ plus JE. So 2 into GJ plus again EF and HG are same. So EF 2 into EF plus FK and KH are same. FK and KH are same. 2 into FK. Then 2 into what is arc length of GJE? Again GJ we will be considering. Again S is equal to R theta. So what is R here? It is R1 into theta is nothing but pi by 2 plus alpha. You have to take angle here, pi by 2 plus alpha plus EF again, let us calculate later, plus Fk. Fk is nothing but R2 into pi by 2 plus alpha here. Earlier it was minus alpha in open filtrate, but here it is pi by 2 plus alpha. Very important to remember. This is length of the open filtrate, length of the cross filtrate. Again we will be looking what is EF. EF is nothing but, here EF is equal to O2M. Same story. I will consider a triangle O1, O2, M. Hypotenuse square is equal to, this is hypotenuse square. Here this part is hypotenuse square. This is alpha. Very important. This is alpha. Hypotenuse square is equal to opposite square, that is O1 M square plus O2 M square. I want O2 M. I will be taking here O2 M square is equal to O1 O2 square minus O1 M square. So I will be rearranging this. I will be removing the square. O2 M will be equal to O2 M square equal to O1. What is O1? O1 is equal to, I will be writing O2 M square is equal to, what is O1 O2? O1 O2 is nothing but this distance. O1 O2, that is nothing but x square. O1 O2 x square is there, x square. O1 M. So here O1 M, I will consider the line segment. O1 M is equal to O1 E plus ME. O1 E plus ME. O1 E is nothing but this one. So this is a radius. O1 E is nothing but radius R1 plus ME. ME is mechanical engineering. Yeah. ME is O2F. This is a O2F. This is ME R2. This is O1 M. Very important here. Earlier it was R1 minus R2. Here it is R1 plus R2. You have to observe here. Minus R1 plus R2 whole square. This is a change here. After that again I will be applying O2M. O2M is equal to square root of x square. I will take it common here only. 1 minus R1 plus R2 divided by x whole square. Got it? After that, apply binomial theorem or apply the root first. It will be x into 1 minus R1 plus R2 by x whole square with this root. You are applying binomial theorem only for this. So it will be using binomial theorem. X into same thing 1 minus R1 plus R2 by x whole square into 2 factor 1 by 2 factorial, that is nothing but 2 plus goes on. So we will be considering only two terms. Multiply x here, x minus, if I multiply x, this x and this x will cancel. R1 plus R2 whole square divided by, again x and x square will get cancelled. I will be left out with 2x. This is my O2M. Why I have calculated O2M is because of EF. EF is nothing but O2M. Then I will substitute this value in length equation. So 2 into, again, here also you can take it common, pi by 2. Pi by 2, if you take common, pi by 2 R1 plus R2. Got it? Then alpha plus, if you take alpha common here, alpha R1 plus R2 plus EF. What is EF? Directly you can write EF is nothing but x minus R1 plus R2 whole square divided by 2x. Got it? Then I will be multiplying 2. Before that, I will be knowing what is alpha. What is alpha? I will be calculating here from triangle O1, O2, M. I will consider O1, O2, M. Sin alpha will be equal to opposite side. This is the opposite side, O1M divided by hypotenuse. Hypotenuse is O1, O2. What is O1M? Directly you can write O1M is nothing but R1 plus R2. What is O1, O2? X. This is sin alpha. Again, for small angles, sin alpha tends to alpha. Alpha is equal to R1 plus R2 divided by X. So this is one of the change I told in case of cross pultride. Earlier sin alpha was R1 minus R2 by X. Now it is R1 plus R2 by X. I will be substituting this. I will take 2 common. Let it be 2 pi by 2 R1 plus R2 plus what is alpha? R1 plus R2. So R1 plus R2 into R1 plus R2 is R1 plus R2 whole square divided by X plus X minus R1 plus R2 whole square divided by 2X. Then what I will be doing? I will be taking the common. This will be, if I multiply with 2, this is pi into R1 plus R2 plus, again here 2 goes here. Let it be 2 outside only. I will write one more step. 2 into pi by 2 R1 plus R2 plus, I will take R1 plus R2 whole square by X as a common, 1 minus half plus X. So 2 I will be taking pi into R1 plus R2 plus, again it will be R1 plus R2 whole square divided by 1 minus half is half, 2x. So 2 will get cancelled. R1 plus R2 whole square by x plus 2x. So this is an equation for length of cross belt drive. Very important thing you have to remember again here is angle. What is the angle of contact for larger pulley? So this is a larger pulley or driver. What I will be doing is total angle is 180 degree plus alpha. So 180 degree plus 2 alpha. For smaller pulley, 180 degree plus 2 alpha. Smaller pulley, 180 degree plus 2 alpha. So this is one of the differences in case of cross belt drive. Theta, directly what you can say, theta of large is equal to theta of small, 180 plus or minus 2 alpha. No, 180 plus 2 alpha. Whereas in case of open belt drive, theta large and small will be 180 plus 2 alpha if it is a larger pulley. If for smaller pulley, 180 minus 2 alpha. And sin alpha is R1 plus R2 by X in case of cross belt drive, whereas sin alpha is equal to R1 minus R2 by X in case of open belt drives. So this derivation you have to observe, and this is the length of cross belt drive. The difference here is, if it is a open belt drive, you will get R1 minus R2. If it is a cross belt drive, R1 plus R2. That's all. This is the only difference. Middle term will be varying here. So in the last class, we derived the length of open belt drives and length of cross belt drive. So the difference between those two is alpha. Sin alpha will be equal to R1 minus R2 by X in case of open belt drive. sin alpha is equal to R1 plus R2 by X in case of cross peltre. Another important thing here is angle. The angle of larger and smaller pulley will be equal to 180 degree plus 2 alpha in case of cross peltre. In cross peltre, angle of larger pulley will be equal to angle of smaller pulley, that will be equal to 180 plus 2 alpha. Whereas in case of open peltre, it is different. Angle of larger pulley is 180 plus 2 alpha, smaller pulley is 180 minus 2 alpha. Where we have to consider this condition? For that, very important concept is, now we are deriving the ratio of belt tensions. So here we have to use the condition of larger pulley and smaller pulley. From open peltre or cross peltre, I will be considering only one pulley, that is a driven pulley. Here I will be considering driven pulley for analysis. So this is a driven pulley for analysis. This again driven pulley or driven wheel, I will be considering it, and this has connected like this. Again, what we have seen, this is T2 and this is T1, where T1 is tension in tight side, T2 is tension in slack side. Tight side means it is having more tension, slack side means it is having less tension. Then I will be considering a point at which the force is acting. So that is nothing but, from here I will be writing a force, that is F. This is nothing but tension force T. Again, this point I will call it as P. Another force is acting here. This is on tension side, it is having more tension, delta T plus delta T. So this is only T, this is T plus delta T. This is T plus delta T and this is T. This is acting at a point Q, this is acting at a point P. I will be joining these two. This I will be joining. This is perpendicular and this is also perpendicular. The angle between this is delta theta, that is change in angle. So apart from this, one more force is acting, that is, one is frictional force F and another one is normal reaction. This normal reaction tends to move the belt away from the pulley, that is normal reaction, and this is frictional force while having tension. Let us see what are the different forces acting here. Number one is T plus delta T at Q and T at P, then normal reaction, then frictional force. These are the four forces acting on the system. Let us write a diagram which represents only the forces, that is nothing but free body diagram. I will represent here, this is O and this is P. From P, this T is acting. Again, this is Q. From Q, T plus delta T is acting. Then I will write like this. I will join these two. These two will be integrated at some point. In that point, you will be having frictional force, that is nothing but mu into Rn, then a normal reaction. This is the free body representation. This is the force representation using free body diagram. This is free body diagram. Let us solve this. First, I need to resolve the forces horizontally and vertically. If I resolve the forces horizontally and vertically, I will get the solution. Let us consider horizontal forces, algebraic sum of horizontal forces equal to 0. I will treat right hand side forces positive. So you will be having this Rn, this is acting right hand side, so positive. Then where is another one? This is T. If I resolve this into horizontal and vertical, you will get T. T into, since it is, the angle is given with respect to opposite side, it is sine theta. So minus T into sine delta theta by 2. That is a resolution for these forces. Then again, one more force is acting, T plus delta T. This will be acting here, this will be acting here. Again, this is also sine plus, minus, it is acting away from that, T plus delta T sine delta theta by 2 equal to 0. Only three forces will be acting here. One is Rn, another one is T acting that side, and T plus delta T is also acting that side. So I will be simplifying this. Rn minus T sine delta theta by 2 minus T sine delta theta by 2 minus delta T into sine delta theta by 2 equal to 0. So delta T itself is small. We can neglect product of small quantities. So this will be neglected because it is a product of small quantity. I will be considering this Rn minus 2T sine delta theta by 2 equal to 0. Again, for small angles, sine theta tends to theta. So sine delta theta by 2 tends to delta theta by 2. I will write this Rn minus 2T delta theta by 2 equal to 0. So Rn is equal to T into delta theta. This I will call it as equation 1. But here you should not cancel here, it is wrong. After writing this, mathematically you can cancel because sine theta tends to theta. This is a small angle conversions. Next, another one we will take summation of vertical forces is equal to 0. Treat positive for upward forces. So what are the upward forces here? Again we have F, it is a frictional force. I will write F. Then frictional force F plus, again T is there. Here I need to consider with respect to vertical component. So here I have to consider cos T into cos delta theta by 2. So this will be acting horizontal like this. Then this will be acting vertical like this, vertically upwards. That's why T cos theta by 2 minus this force will be acting vertically downwards. Since it is acting downwards, we will be considering negative. T into delta T cos delta theta by 2 equal to 0. Again we will be simplifying this. F plus T cos delta theta by 2 minus T cos delta theta by 2 plus, minus delta T into cos delta theta by 2 equal to 0. Here you cannot cancel this because for small angles sin theta tends to theta, but for small angles cos theta tends to cos theta tends to 1. Cos 0 is 1. That's why for small angles cos theta tends to 1. This value will be 1. Very important thing. Usually people will do mistakes here. They will cancel all the terms and they will make 0. If you make this 0, we will make everything 0 in the derivation. So be careful here. These two will get cancels. Many people will cancel this also because of product of no. This is cos term. You have to take precaution whenever you are using cos term. So F minus F is equal to delta T. If I write this, what is delta T? Sorry, what is F? Mu into Rn is equal to delta T. That is the equation for this. If I rearrange this, Rn is equal to delta T divided by mu, where mu is coefficient of friction. I will be equating 1 and 2. I will write here equating 1 and 2. We get what we get. Rn is equal to T into delta theta will be equal to delta T divided by mu. So what I have to do? I have to remove this. I will be arranging T in left hand side and other parameters in right hand side. So T will be going here. Mu will be equal to 1 by T delta T. I am rearranging the equation in such a way that one variable on left hand side and other variable on right hand side. Then what I will be doing? I will be doing integrating. So integrate above equation. We get what happens? Integral of this will be mu into mu is constant. Integral of delta theta is equal to integral of 1 by T delta T. Mu into integral of some variable is theta. So 1 by T integral of this is log x. So usually we will call it as ln x. Log to base e we will take. Then if I consider ln is nothing but log of e. If I use log, it is log to base 10. This you have to remember in calculator. It's very important. I will be using ln x. Ln x is nothing but log e. X is here, it is not x, it is t. So again here there are two limits. One is maximum and another one is minimum. So maximum is t1, minimum is t2. So ln of t, if I rearrange this, ln of t1 by t2 into mu theta. If I remove ln here, then what I will be doing? T1 by T2 is equal to e to the power of mu theta. This is the ratio of driving tensions, where T1 is tension on tight side, T2 is tension on slack side, mu is coefficient of friction, and theta is angle of lap. So in sometimes they can ask angle of lap for larger pulley, angle for lap for smaller pulley. If both are given, here we are considering driven pulley. You have to consider for smaller pulley or driven pulley. This is very important, where you are going to use actual theta here. So what is the theta for cross belt race? So theta s will be equal to 180 plus 2 alpha. This theta will be varying here, and theta of smaller pulley for this is for cross belt drive, this is for open belt drive. 180 minus 2 alpha. See here you are using this. So this is one more difference. In the problem they will ask to find out ratio of driving tensions, or sometimes you have to use some other equation like T1 by T2 you have to use, and initial tension you have to use. Using these two equations you have to calculate T1 and T2. After that they can ask power or anything. So this is generally they will be asking in the examination. Let us solve some of the simple numerical problems on the belt drives. Let us recall the formulas. So first we have used centrifugal velocity ratio. Velocity ratio is nothing but it is a ratio of speed of driver to the speed of driven. That will be d2 by d1. If you consider a slip, d2 divided by d1 into 1 minus s by 100. So even if you consider a creep, the formula will be changing. This is very important. 1 refers to driver and 2 refers to driven. Very important thing. Then we saw length of the belt drive. So length of open belt drive, first length of open belt drive is nothing but pi into R1 plus R2 plus 2x plus R1 minus R2 whole square by 2x. This is minus. Here we saw one more thing, that is theta for larger pulley is 180 plus 2 alpha, theta for smaller pulley is 180 minus 2 alpha. Very important thing. Then another one is for cross belt drives. Again length we are calculating. Length of the cross belt drive is pi into same equation R1 plus R2 plus 2x plus, instead of minus here you will be getting plus R1 plus R2 whole square by 2x. Then another important thing is this one. If you take larger pulley or if you take smaller pulley, it should be 180 plus 2 alpha. And here theta should be in radians. Whenever you substitute the value of theta, it should be compulsorily in radians. Theta should be radians. Conversion for this is 180 pi x by 180. So we know for radian it is pi, for degree it is 180. Whenever you want to convert degree to radian, simply pi should be in the numerator, pi x by 180. Whenever it should be the degree to radian, it should be pi x by 180. Whenever it is radian to degree, 180 x by pi. So 180 x by pi we are not using, just to remember pi x by 180, theta should be in radians. Then another one is power. Power is nothing but T1 minus T2 into velocity. Again velocity you know, velocity is equal to pi d1 n1. It is also equal to pi d2 n2. Velocity. Another one important thing is you have to calculate T1 and T2 based on some conditions. So what is that? One is they will give initial tension T1 plus T2 by 2, and another one they can give ratio of driving tension T1 by T2 e to the power of mu theta. Compulsorily theta should be a smaller pulley here. So if only one theta is given, no problem, directly substitute it. If two thetas are given, larger and smaller, then you have to use smaller pulley here. So these are the very important formulas we are going to use while solving the problem. Let us see problem number 1. This is a problem number 1. Just I will be taking the data. Power is to be transmitted from a shaft to another shaft by a means of belt drive. This is belt drive. The diameter of the larger pulley is 600 mm. Larger pulley is 1. So D1 is 600 mm. I want everything in meters. Divided by 1000. Milli means 10 to the power of minus 3. 1 by 1000. So it is 0.6 meter. I don't want diameter, Baba. I want radius. So radius is nothing but diameter by 2. This is 0.3 meter. Then and that of smaller pulley is 300 mm. Diameter of smaller pulley is 300 mm. So 0.3 meter. If it is R2, it is 0.15 meter. The distance between the centers of the two pulley is 3 meters. What is this data? This is x. Center distance. X is equal to 3 meters. If the axis of two shafts are in the same plane and parallel, that is the definition of belt drives, find the length of the belt drive. So you have to consider length of open belt drive, length of cross belt drive. That's all the problem. Directly I will be using, I need to calculate length of open belt drive. So L is nothing but pi into R1 plus R2 plus R1 minus R2 whole square by 2x plus x whole square by x plus 2x. So this is not 2. 2 will get cancels. So pi into R1 plus R2. R1 is 0.3 plus R2 is 0.15 plus 0.3 minus 0.15 whole square by x plus 2 into 3. This is 3. Everything should be in meter. If you calculate, it will be turning on to 7.42 meter or 7421.2 mm. This is the total length of the drive. Write it in meters better. Next, length of cross belt drive. L is equal to pi into R1 plus R2 plus R1 minus R1 plus R2 whole square by x plus 2x. If you substitute the values, pi into 0.3 plus 0.15 plus 0.3 plus 0.15 whole square by 3 plus 2 into 3. If you calculate this, you will be getting around 7.48 meters or 7481.2 mm. So there is no much difference in open belt drive and cross belt drive. One more important problem we will be seeing, that is the driven pulley of 400 diameter. The driven pulley of 400 diameter. So D2 is 0.4 meters. Directly we will write, and a belt drive runs at 200 rpm. That is speed. N2 is 200 rpm. The angle of lap is theta 165 degrees. That is the angle of lap they have given, and the coefficient of friction between belt material and pulley, that is mu 0.25. By looking into the units, take the values. If it is in degree, it is theta. If it is having no unit, it is mu. If it is in rpm, it is a speed. If it is in meter, it is a distance or diameter. Find the power transmitted. You have to calculate power, and they have given the initial tension of the belt is 10 kilonewton. It should not exceed 10 kilonewton. Let us solve this problem. Very easy, but looks like complicated. It is not so complicated. You have to get the value of power. What is the power? Power is nothing but T1 minus T2 into velocity. So first you have to get the value of T1, then you have to get the value of T2, then we have to calculate V. Whenever mu is given, you have to use T1 by T2 ratio. Whenever initial tension is given, again it is, you have to use T1 plus T2, initial tension relation. First I will be using T1 by T2 relation. So I know T1 by T2 is equal to e to the power of mu theta. And theta is given. Theta is nothing but 165 degree. 165 degree, I have to convert this to a radian. Pi by 180 you have to multiply. So pi into 165 divided by 180. So if you multiply this value, you will be getting it is 2.879 degrees. No, sorry, radians. 2.879 radians. Now you substitute the value e to the power of mu. Mu is nothing but 0.25. Theta is nothing but 2.879. This is the T1 by T2 value. Multiply these values into 0.25. Take e power answer. Then you will get T1 by T2 is equal to 2.054. You rearrange this. T1 is equal to 2.054 T2. So if I write like this, 21 minus 2.054 T2 equal to 0. Call this as equation A. Then you use initial tension. Initial tension they have given. Initial tension. So T0 is equal to T1 plus T2 by 2. T0 is how much? 10 kilonewton. 10 into 2. T1 plus T2. I am keeping T in kilonewton, remember, because this is in kilonewton. So T1 plus T2 is equal to 20. This I will call it as equation B. Solve A and B in your calculator. Don't do nothing, just solve A and B. How to solve this? You have two equations. A1 x plus B1 y is equal to C, then A2 x plus B2 y is equal to C2. These two values you have to give. First you have to give A1. What is A1 here? It is a coefficient of T1. Coefficient of T1 is 1 here. You have to give A1 1, and B1 you have to give minus 2.054, 2.054, enter. You have to give minus value, remember. Then C1 value is 0, there is a 0 here. Then A2 it will ask, A2 is second equation coefficient, that is T1 plus T2 is equal to 10, this one. So T1 is 1, A2 is 1, T2 is 1, A2 is 1. Then C2 is 20. So you give 1, 1, 20. Then you solve, then you will get x and y values. Then you will get T1 13.45 kilonewton, then T2 6.55 kilonewton. These are the values you will be getting. Once if you calculate this, 50% of the problem is over. Then you have to calculate power. Power is nothing but T1 minus T2 into V. V you have to calculate. What is V? Pi D2 N2. Here they have given D2 and N2. Data is corresponding for driven pulley. So pi into D2 into 200. So pi into 0.4 into 200. It is 251.32 meters per minute, because N is in RPM, D is in meter. So meters per minute. If you want to convert to meter per second, so divided by 60 you do, then it will be 4.18 meter per second. This is the velocity. Substitute here, T1 is 13.45 minus T2 is 6.55 into velocity is 4.18. So it is 28.9. Unit you have to write whether it is in watts or kilowatts. So already this is in kilonewton here, because I have given this value in kilonewton. So that's why it is in kilonewton. Kilonewton meter per second is kilowatts. This is the answer.